So graphing inequalities is not a whole lot different than graphing equations. There's going to be just a few exceptions. So, normally we just graph like we would an equation. For either greater than or less than, we're going to use a dotted line. And then for greater than or equal to, less than or equal to, then we use a solid line like normal, because we're showing that those points are included. When we don't have the or equal to, we don't want to include the points on the line. It's just anything greater than or less than. So once we graph like a regular line and we use either the dotted or the solid line, then we're going to test the point 0, 0 to determine which side makes the inequality true. Which side makes the inequality true, to decide what side to shade. So to decide where to shade. So we want the parts that work to be shaded. So, for example, if we had x plus 3y is greater than 6. So let's graph this just like we would graph x plus 3y equals 6 and use the, looks like intercepts might be quick. So when y is 0, x is going to be 6. When x is 0, y would be 2. Now I'm going to have to remember to use a dotted line because it's just greater than. So I have the point 6, 0, 0, 2. I'm going to use a dotted line. Okay, now I'm going to test 0, 0 here. So is 0 plus 3 times 0, is that greater than 6? Is 0 greater than 6? Not true, meaning 0, 0 should not be shaded, which means if the below is not shaded, then above would have to be. So then we shade everything above. If you want to test, maybe like, let's see, we want to test one more, maybe 2, 2. 2, 2 should be shaded, so it should work. Is 2 plus 3 times 2 greater than 6? Yeah, that's me, 8. 8 is greater than 6. So that makes me sure that I shaded the right side. Okay, so that's when we have just one inequality. We could also have, if it's saying, one inequality or the other, we would shade both parts. If it was one inequality and the other, we would shade just the intersection. So, but now we're going to get into systems, which basically is the same thing. So we're going to shade, we're going to have a system of inequalities. System of inequalities. So we're going to, the solution is where the shaded areas overlap. Oops. Shaded areas overlap. So let's say, for example, we have x plus 4y is greater than or equal to 4, and y is less than negative 2x plus 3. So for my first line, we'll do this the intercepts way. When y is 0, x would be 4. When x is 0, y would be 1. Oops. So 4, 0, 0, 1, and that should be solid. Now that one, so if I want to test 0, 0, Is 0 plus 4 times 0 greater than or equal to 4? Is 0 greater than or equal to 4? No. So I should be going above. So I'm not gonna shade it, I'm just gonna put little arrows showing I'm going above. So then when I figure out where this overlap is, I kinda know how to do that. Now I'm gonna use red for the next one. Now this one, I can do my slope-intercept way, so I'm gonna go up 1, 2, 3, and then do my slope down 2, to the right 1, down 2, to the right 1. Now this one should be dotted. So let's test this. Does 0, 0. So is 0 less than negative 2 times 0 plus 3? Is 0 less than 3? Yes. So that means I should be going where 0, 0 would be shaded down this way. So now where they intersect is going to be just right here. You can see the book has some better visuals of showing the overlap with different colors, but hopefully you should kind of get the idea. This is where they would overlap. Make sure I show that this is dotted. So that would be my solution, where they intersect. Let's do one more. These ones are where we have more than just 2 inequalities. 2x minus 3y is less than or equal to 6. Y is greater than or equal to 0. Y is less than or equal to 4. And x is greater than or equal to 0. So I actually have 4 inequalities here. So I might be creating kind of like a 4-sided shape is what's going to happen. So my first equation, let's do the intercepts way. When y is 0, x is 3. When x is 0, y would be negative 2. So 3, negative 2, this should be solid. So I'm going to test 0, 0 now. 2 times 0 minus 3 times 0, is that less than or equal to 6? Is 0 less than or equal to 6? Yes. So I should be going up. Okay, now for y is greater than 0. Do this in red. Y is greater than 0. So remember, a y equals equation is a horizontal line. So the horizontal line, this is the x-axis. And if we're saying greater, we're looking at above the x-axis. So y equals 0, greater. Same thing with that x. This is going to be the y-axis because it's a vertical line at 0. And again, it's greater, so it should be to the right. Now the last one is another horizontal line, because if it was y equals 4, it would be a horizontal line at 4. I'm going to draw a solid line because it is or equal to. Now less than 4 means I'm going to be going down. Less than. So it looks like my intersection is going to be this middle area right here. Now if I was asked to find what these endpoints are, looks like some of these would be pretty easy to figure out. Looks like right here, that one was the point 3, 0. I've got my origin 0, 0. Then I've got the point 0, 4. But now over here, what would that be? Well, I know my y value is 4. So if I plug it into my equation, 2x minus 3 times 4, the other equation I'm trying to intersect it with the blue line, 2x minus 12 is 6, add 12, 2x is 18. Notice that's just an equal sign because I'm right on the line. So x is 9, which looks about right, 9, 4. So maybe we would guess what the intersection points are.